Jai Hind everyone. Today we are going to see Computer Network, Unit 3, Network Layer. I am Rupak Kumar, Assistant Professor, Department of Information Technology, Ajay Garg, Engineering College, Ghaziabad. So we start with the first lecture of this network layer, in which we just come to know the position of network layer. Means we have a network layer in between transport and data link layer. Here we can see these are the services which is provided by the network layer. Network layer is basically very important layer in terms of networking, sending data, or we can say in terms of IP address, MAC address and all. And routing is also one of the important services which is provided by this transport layer. So routing is also an important layer. So in this we can see we have a multitasking, we can have a routing protocols, address resolution protocol. These are the some very important protocol which we found in a network layer itself. Another important is networking, internetworking, packaging, addressing, routing and fragmenting. These are the some important tasks which is done by the network layer. Network layer is in between your data link and transport layer. This is the third layer of your computer network OSI model. Now, what is the duties which is given by this network layer? So if we talk about the duty of network layer, we can say we have a networking, we have addressing, routing, packaging, fragmenting. These are the some important tasks which is done by this network layer. Now, in this network layer, first we come to know about the IP addresses. What is IP addresses? Basically, it is a 32-bit address, and that uniquely and universally defines the connections of a device. Means when we connected in a network, we can say we must have two types of addresses. One is your physical address, another is your logical address. Physical address is concerned with the devices, and it is given by the manufacturer company. When he manufacture these devices, they just insert the MAC address, that is what called physical address, medium access control address, and it is an inbuilt address. It is never be changed once it is born in a device. So first address is your MAC address, physical address, same thing, and next is your logical address, the another important address which is in the computer when they are connected, computer or any device, any network device, when they are connected in a internet. So for this we have a IP address. This is a logical address. So IP address is are of two types, we can say. Nowadays we have found the two types of IP address. One is version 4 and another is version 5, version 6. 5 is created but it is not in use. So we have only 4, IPv4 and IPv6. So we concerned with first types of IP address is that IPv4 addresses. So when we concerned with IPv4 addresses, it is basically a 32-bit address, and that is uniquely and universally, means throughout the world. It's define the connections of a device. Means we connect the device for example, we can take a computers, a routers, any component that is what connected in internet, and that is what connected for networking. They must have the IP address. So this is the very important logical address. So we discussed the address space notation, classful, classless, network address, NTA, network addresses translation further. So first is your IPv4 address. It is basically 32-bit address. It is divided into 4 chunks: 8-bit, 8-bit, 8-bit and 8-bit. So these are the 32 bits concerned with this IPv4, and it is basically IP address is basically written in a binary itself, but we are generally see the IP address like this: 192.168.10.11. This is the format of your IP address, but it is in decimal concern. But for understanding the IP address, we must convert these addresses in a concerned binary itself. Whatever it is, you can convert it. So we must know to convert it, because understanding this IP address, we must convert these address to binary number. So IPv4 address are unique and universal. What does this mean? Unique and universal means it is basically unique throughout the world. It is basically different for every device which is connected in internet. As IPv4 is concerned, if you talk about the history of IPv4, it's come to end around 1992. Means the number of IP, around 4 Arabs and all IP address in the IPv4 is full at the time of 1992, around 1992. And after that, we are just convert this IP address to classless. It was the class, it was divided into classes. Then we convert and come for the next types of IP, that is what? Classless IP address. So first we concerned with class full, then we go for the classless IP address. Now the addresses space for IPv4 is basically 2 to the power 32. Means we have a 8-bit 4 chunk of addresses. So each 8-bit means it's a total 32. Means number of computer connected with these IP addresses must be 2 to the power 32. That is what we concerned with 4294967296. This is the number of computer we can connect in our IPv4 address. But as your knowledge, we can say that it is full around 1992 itself. Means the device around the world is taken these all addresses. Now we are the without address in 1992. Then so it is a class, which is divided into class, that is what? A, B, C, which is in use, D is not in use. And after that, this class, we come for the, after 1992, we come for the classless. We come for the classless IP address. So this is what the main concern, that we have in a class. Now we first discuss the class of IP address, then we come for the classless IP address. So this is what the format. We always concerned, because as a human, we are not concerned with binary number. We are not aware or very much fast understand this binary number. We understand the digital only. That's why we just write it in a digital format, IP address, but it can be written in a binary. So decimal format is not in use for experimental purpose and all, for studying purpose. We just have to convert these decimal number to these IP address. This is what the 31. How it is 31? We can say it's a 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, and so on. But it is a 1, it is a 2, 4, 8, 16. When we add all these, it is a 32. That's why we can write these in short like this also. We can convert this IP address to our respective binary number. Means the decimal number is converted to binary. Clear? So we must understand how it is converted, what is the value of these, vice versa. We may need the decimal number, we may also need the binary number. Now, what is logical address? IP address, we come to know IPv4 6, unique and universal, binary notation, dotted decimal notation with class full and classes of IP address. First, we start with the IPv4 address. Basically, if we talk about the IPv4 address, means the internet protocol address, this is are of 32-bit length, as we can discuss. So it gives us a maximum of 232, 2 to the power 32 addresses. That is what concerned with 4 Arab around, and addresses are referred to as a IPv4 addresses, or simply a IP address if there is no any confusion. So this means that theoretically, if there were restrictions more than 4 billion or 4 Arab 29 crore 49 lakh 67,000 devices could be connected to this internet. So the actual number is much less because of the restriction imposed on the addresses. So world population is often used to refer to the total number of humans currently living was estimated 7.9 billion around 2021. So this is not sufficient for to give IP address to this much of people's devices in IoT and all. So we just switch to the next IP address, that is IPv6. So we can say the need of more addresses, if addition to the concern about the IP layer, so motivated a new design of IP layer called a new generation of IP address, that is IPv6 version. So in this version, the internet is basically use 128-bit address. IPv4 is basically of 32-bit address, but it is a 128-bit address. So it is as much as if we connect all the device throughout the world, throughout the universe, then also it is not full. So this is a very, very much many numbers concerned with the 32-bit. So we are just on era of now IPv6 address. First we confirm and concerned with IPv4. So we study first IPv4. What is the IPv4? Basically, it is an IP address, is a uniquely and universally. Always we say it is a unique and universal, defining the connection to the host or routers to the internet. So they are unique in the sense that each address is defined one and only one, means every device is uniquely connected throughout the world, and every address is unique and only one, that is what connected to the internet. So two devices on the internet can never have the same addresses at that time, at same time. They cannot have the same addresses. So IPv4 address are universal, and it is the sense that the addressing system must be accepted by any host or that wants to connect it to the internet. So the IP address is addresses of connections, not the host or the routers, because if the device is moved to another network, the IP address may be changed. Now we concerned with class full IP address. So we can say IP addressing at the inceptions used to concept of the classes, means there is a class in an IP address, and this architecture is called class full addresses of the IP. It has a 32-bit IP address, is a hierarchical and divided only into two parts. The first part of that address means that 32-bit is divided into two parts. First part is called prefix, and the next part is called network ID. Prefix and network ID. And the second part of the addresses is called a suffix and defines the node, and it is called a connection of a device to the internet, that is host ID. Means we divide 32-bit addresses in two parts, prefix part and suffix part. Prefix part is basically called net ID and suffix part is called host ID. Means number of network is defined with this n bits, and then 32 minus n is defined with the host address. So this is what the format of your class full addresses. Here we can see how we connect these network with the help of wireless LAN and IP address. Now concerned with the IPv4 was first designed as the fixed length prefix and referred to as a class full. Means there is a fixed length for prefix and suffix. And class full address, the address space is divided into 5 classes. A, B, C, D, E, and each classes occupy the same part of the address space. So first we concerned with accommodation both small and large network. So 3 fixed length prefix were designed. Means we fixed the first A, B, and C as a suffix and prefix so that we can connect our computer to the network. In start it is designed like that. In this we have a class A. There some part 1 byte, means 8 bit is for network ID, and rest of 3 byte means 24 bits is for host ID. Another in class B, we keep 2 bytes as a network ID, or we can say 16-bit as a network ID, or 16-bit or 2 byte as a host ID. Here is a 1:3, here is a 2:2, here is 3:1. This is the ratio of net ID and host ID divided in a class full address of the IP address. And rest 2, that is class D and class E is concerned. Class D is saved for multicast address and class E is reserved for further use. So this is what the class architectures of class full IP address, in which we have 5 classes A, B, C, D, E. In first 3 we divided these in a network part and host part, and last 2 is reserved for multicast and reserved for future use. So this is not in use. Now, how much address space is there? This is what the number of around 4 Arab 294 crore, like that. And then we can see here, if we have a network part is 8-bit and 24-bit is our of host part, then we can see in this address space maximum 50% of computer is basically, if we connect all these IP address in a IPv4, and 50% is concerned with a class A only. Class A में कितना रखा गया है? 50% computers. Then 25% of that is kept in a class B. Then 12.5 and 6.25 and 6.25 in the class C and D. You can see the scenario like that. If we have this is the IPv4 Internet Protocol version 4 addresses, then we can say this is what the class A, that is 50% of this whole addresses. Then we divide these. This is what the class B, that is 25% of these addresses, and this is what the C, that is class 12.5% of addresses. Then this is what the D and E, it is basically 6.25% of addresses. This is what the scenario where we divide these addresses in like this. Clear? So you can see here the prefix part. If we concerned with binary number, and we come to know how we come to know which class of IP address is this, and we can see if 0 is in the start of this IP address, means if the prefix is 0, then we can say the classes is A class. If any binary IPv4 number, we can see if it start with 0, it must be a part of class A addresses. If it start with 1 and then followed by 0, then it must be class B addresses. And if it is followed by 11 and followed by 0, then it must be in a class C addresses. And if it is followed by 111 and 0, then it is called a multi, and all 4s, that is what? Reserved for future use. So this is what we can, after seeing any IP address in decimal number, in binary number, we can see first 1, 2 or 3 digit, we can see after seeing these which class of address is this. No, we can see. Likewise in binary, if we talk about in decimal, we can say its range is from 0 to 27. Means if any IP address start from 0 to 127 in a decimal, we can say it is in class A. If any number start from 128 to 191, then we can say it is in class B. Likewise, C 192 to 223, D 224 to 239, and E is 242 to 255. This is what the classes, this is what the number of bits which is reserved for network ID, and these are the first byte of the address start with this decimal number, and it is belong to these classes A, B, C, D. So in binary also we can say if the number start with this, we can say which class address is this. In decimal also we can say which class addresses is this. After seeing this, we can say or define the things. Clear? Likewise, now come to the class A. First, we concerned with the class A. As we know, if we talk about the class A, its range is must start from 0 to 127 in a binary number. And if we concerned with the network ID, mean in class A, if we talk about the network ID, we see here it is R of 8-bit network ID and 24-bit host ID. So we must remember this, and we can understand. Now, how to identify the class A address? So first bit, if first bit is reserved to 0 in a binary notation, is called it's a class A, and its range of first octal is 0 to 127 in a dotted decimal number. Then we can say it is decided that which class addresses is this. So likewise, we can say if we concerned with class B, then we can say we have a network ID of 16 bits and host ID of 16 bit. So how to identify this? First bit R must be reserved for 10. If it is 10, then in a binary notation we can say it's belong to class B. And first, if we talk about the range of first octal is in between 128 to 191 in a dotted decimal notation, then it is belong to class B. So after seeing these, we can say which class is belong to this. Next is your class C. If we talk about class C, means C net ID is basically network ID in a class C is 24-bit. You can see here. Now, all the 8-bit 3 part is reserved for a network part, and host ID is less here. Its a number is 8 only, means 8-bit is reserved for host ID. So it's used for a very small companies, very small company. It's basically a mediocre company. It's a very giant company. More than crore of computers are connected in this network. So this is what the host ID and net ID for this class C address. If we concerned with 110, then it must be binary notation. If we concerned with 192.223, its decimal is basically it is in a dotted decimal notation. Then we can say it is concerned with a class C network only. Basically, C is basically widely used network. We always see the our IP address must be 192.168.10.10. This range was IP address we always see, because we concerned with a small company, school, college, and organization. So that's why we have to provide these range of IP address that is concerned with not too many hosts with this per network. This is what the class C IP address. Now concerned with D, as we can say, class D is not divided into network ID and host ID. Basically, how to identify the class D address? We can identify with the help of these 1110 in a binary notation and 224 to 239 in a dotted decimal notation. This is the class D. It is not divided. There is no any division for this bit, but we can say if we see in start 1110, it is basically belong to class D. And final and last is your class E. Class E is not divided. It is also not divided into network ID and host ID, but we can identify that this IP address belong to class D, E or not. We can concern with this 4-bit that is reserved in this class is 4 times 1 in a binary notation. And if we concern with the range of first octal is that is it is between 242 to 255, then it is concerned with dotted decimal notation. So this is what the class E IP addresses. This is all about your class A, B, C, D and E IP address. Now, numbering systems. Okay, we'll see the next lecture, numbering system, and reviewed in a how we concerned with the class full IP address. So thank you for today. Thank you.